The moment generating function of a random variable x is given by mx of t equal to 2 by 9 plus 1 by 9 e power minus t plus 1 by 9 e power minus 2t plus 2 by 9 e power t plus 1 by 3 e power 2t, where t varies from minus infinity to infinity. We have to find probability of x greater than or equal to 0. That is, we have mxt equal to expectation of e power tx, and we have to find x greater than or equal to 0. This we can find directly from the given equation only. That is, wherever here x value will be minus 1 into t. So x will be minus 1. While here it will be 2 into t. X will be 2. So this is a direct question and we can find out the answer. And the answer is, so from the equation, direct equation, we can find out the answer as 7 by 9. Fourth option is the correct answer. Next question. In a sequence of Bernoulli 1 by 2 trials, the probability of getting a third success at trial number 7 is. That is, it as you can see is given which follows Bernoulli distribution, and the probability is 1 by 2. So here P equal to 1 by 2. And we have to find out the success of getting third success at a trial number 7. So at 7th trial, if we want to get the third success, till 6 we have to get 2 successes. That is, P of x equal to 2 equal to 6C2. Out of 6 trials, we have to get 2 successes, and the probability will be 1 by 2 power 2 and 1 by 2 power 6 minus 2. And the third success we should get at the 7th trial. So that we can find out separate. X equal to 1 equal to 1C1, 1 by 2 power 1 and 1 by 2 power 1 minus 1. Using these two equations, we have to find out the probability of getting a third success. That is, probability of getting third success is equal to probability of x equal to 2 into probability of x equal to 1. This we can find out, we can simplify these two equations and we can find out the answer as 15 by 128. That is the first option. 15 by 128 is the correct answer. Now, next question. The moment generating function of a random variable x is given by mx of t equal to 1 by 9 minus e power t 7 power 17, where t varies from minus infinity to infinity, and then find out the expectation of x. We have seen the same question previously. Here the question is same, the numerical values and everything is same, but here we have find out the variance of x divided by expectation of x. Using the same question they have given to find out the expectation of x. So we can use the same formulas, that is d by dt of mxt equal to mu1 dash when t equal to 0, and d by dt of mxt t equal to 0 t square is equal to mu2 dash. We don't need the second equation actually, but I have written that. So mxt is given here directly. We can find out the first derivative of this and find out the value, and we get the differential value as 136. The fourth option is the right answer for the given question. That is, moment generating function is given and we have find out the expectation mean value for this one, and the answer is 136. Next question. If a random variable x assumes values minus 1 and plus 1 with equal probabilities, and mxt, that is moment generating function, is given such that limit t tends to 0, mx of root t minus 1 minus t by 2 divided by t square is. We have to find the limit of this given value. So we know that mxt equal to, here x assumes two values, okay. One is minus 1. If x assumes value if x assumes value minus 1, we know that mxt will be 1 by 2 e power minus t, and if it assumes value plus t, e power 1 by 2 minus 1 by 2 into e power t will be the value. So here in the problem we got that we have to find out moment generating function with respect to root t. So mx of root t is equal to 1 by 2 e power minus root 3 plus 1 by 2 e power root t. This is the first equation we have to consider. And putting this equation we have to substitute here. In the limit equation we have to substitute 1 by 2 e power minus root t plus 1 by 2 e power root t minus 1 minus t by 2 all divided by t square. And we have to apply the limit t tending to 0, and final answer we will get as 1 by 24, which is the third option. Okay, this is the answer. It is just a mathematical calculations. We have to apply the limit to the given equation and we will get the answer directly. Next question. Let x, y be random variables with joint probability mass function p of x equal to x, y equal to y equal to x c y 1 by 4 power x, where y varies from 0 to x and x varies from 1 to etc. Then variance of y is equal to. Here they have directly given the joint PDF as p of x y is equal to x c y 1 by 4 power x, and the ranges of y and x is also given. So first we have to find out expectation of y square, which is nothing. We can give the by double integration because it is joint probability mass function, and the values of y varies from 0 to x and x varies from 1 to infinity, and give the same equation, and by differentiating we will get the answer as 1. Variance of y is equal to 1. Next question. If x and y are IID chi-square 2 variates, that is 2 is the degrees of freedom, then the moment generating function of 2x minus 3y is. Here in the question it is given that x and y are independent, and the MGF we have to find out for a chi-square variates. We know that MGF for a chi-square variate is 1 minus 2t power minus n by 2. MGF is equal to 1 minus 2t power minus n by 2. Here n is nothing but degrees of freedom, and here it is given as 2. So here MGF is equal to 1 minus 2t power minus 2 by 2, which is nothing but 1 minus 2t power minus 1. And since x and y are independent, we can find out it as MGF for that is m, instead of x we will have 2x minus 3y of t is equal to, first we can find MGF of 2x of t into MGF of minus 3y into t. We can find out it separately and multiply, and we will get the answer as 1 by 1 plus 2t minus 24t square. That is the first option is the right answer. This is also a direct mathematical calculation using this equation, for that is MGF of chi square is 1 minus 2t power minus n by 2. This is the equation. So from all these questions we can conclude that the moment generating function is a very important part. Now the distribution of difference of two independent chi-square 2 variates is. This is a direct question. This can be seen in many questions, many textbooks and everywhere. The answer is Laplace distribution. Just keep in your mind or remember that the distribution of difference of two independent chi-square 2 variates. That is, two chi-square variates are there, both having the degrees of freedom 2. Then the distribution of their difference will be Laplace distribution. That is a direct question. Okay. The mode of f for a distribution is, that is, this is Nadkor's f distribution. Okay, that is a capital F means that it is f distribution, and f distribution is usually denoted by n1, n2. So here n1 is equal to 4 and n2 is given as 8. We have the equation that to find the mode of an F distribution, mod is equal to n2 into n1 minus 2 divided by n1 into n2 plus 2. This is the equation, like we have expressions for mean, variance, and similarly we have the expression for finding the mode of the F distribution, and using this equation we can find out the answer. We can substitute it 8 into 4 minus 2 divided by 4 into 8 plus 2, and we'll get the final answer as 0.4. The first option is the right answer, 0.4. Next question. If x follows binomial n equal to 2, p equal to 1 by 2, y equal to binomial n equal to 3, p equal to 1 by 3, and x and y are independently distributed, then probability of x minus y equal to minus 1 is. See, we have previously seen the questions related to binomial and Bernoulli distributions. Usually we think that binomial and Bernoulli distributions are very simple to learn and we just skip that, okay. But just see the importance of binomial distribution. I think this is the third question that is repeating in this question paper. X is a binomial distribution, y is a binomial distribution, and we have to find out the probability of x minus y equal to minus 1. So we can use nothing but the PDF of this one. F of x we can find out, f of y we will find out, or p of x and p of y, and we will give that directly. P of x minus y equal to minus 1, we'll find out using the, we know that, okay, ncx is equal ncx into p power x into 1 minus p power n minus x will be the equation used here. So using this equation we can find out probability of x minus y equal to minus 1, and we'll get the answer as 25 by 108. The third option is the right answer. 25 by 108 is the right answer. Now next question. If x and y are IID normal 0, 1 variates, that is normal 0, 1 is standard normal distribution, then moment generating function of qx square minus 3y square is. See, again moment generating function, question related to moment generating function has come. Just focus too much on that. So MGF for a normal distribution is nothing but e power mu t plus e power Since moment generating function is very important, we should learn all the equations, like moment generating functions equations for all the distributions. For a normal distribution, MGF equation is e power mu t plus half t square sigma square. This is the equation for a normal distribution. So for standard distribution, mu equal to 0 and sigma square equal to 1. So MGF will be e power half t square. This is the equation. So using this equation, we have to find out the moment generating. This is for mxt. Okay. For mxt, it is e power half t square. We have to find m2x square minus 3y square of t. This directly we can substitute, since x and y are IID, that is independent, we can find out m for 2x square, m for 3y square, and find out the answer. So the moment generating function of 2x square minus 3y square will be 1 plus 1 divided by root of 1 plus 2t minus 24t square. We can get this answer by substituting the value. Instead of x, we can give 2x square minus 3y square. We can either take this at z also. Then we find out mz of t is equal to expectation of e power tz. Using this, we can find out the answer for this question.